So our topic for today is about parallel communication. So although karon dili na siya kayo ingyan na ka-trend ang parallel communication compared to the old times, our time na medyo expensive nga mopalit og mga modules nga based on USB or mga serial na mga buses. I still remember when we are third year man ata to, our school buy a worth 100,000 plus for one piece of USB module for that time. And after one experiment man siguro or two experiment, basta a few experiments, the the school was already the school or the my seniors already broke the module, and they they pay for the amount to fix those USB modules. So in this part, we'll be discussing about parallel communication. So what is a parallel communications? Its evolution, works, characteristics, and when to use parallel communication. So first, parallel communication, okay, has been popular choice when a high-speed data transfer is required. This post entails parallel communications, evolution, history, how it works, characteristics, when to use it, and the difference between the serial and parallel communication. So if you could see the figure below, the first one is about serial communication. So serial communications have RX and TX. TX means transmit and RX at the receiving end. And this transmit depends on the clock cycle. So that's how we do our transmission of data karon, no? So we mostly use serial communications. So but since we'll be using new controllers, we need to discover how to process serial communications and parallel communications in that controller. So in this case, it will be referring to the interfacing of your devices. Meaning, from one different device, you need to transmit a data and will be received by another device. It it means that those two devices from the transmitting end and from the transmitting end and the receiving end will be different devices. Okay. So for example, we transmit from your computer to your controller, through your cell phone to your controller, and etc. So that's how we will be trying to do it. So in terms of transfer for parallel communications, the difference there is that the transmission of each bits of data is transmitted simultaneously. If you could see in the serial transfer, so it will be transferred one at a time. Okay, so it started with, let's say, B7. After it is received, there's a series of bits that is being transferred. Okay, so while on the parallel communication, so it is very very fast since it doesn't take this 8 bits, if this is 8 bits, to be transferred one at a time. It This 8 bits in a parallel communication could be transferred simultaneously at a time. So it will be divided into how many? So daghan kayo. So sir, if parallel communication is very fast, why does it's not anymore commonly used karon? Okay? Most of the transfer karon are more on serial, di ba? So number one, the drawback one of the drawback is the parallel transfer is more expensive in terms of the materials to be used. Meaning, if this one, let's say just practical, if this uses one wire, it uses many wires per bit. So imagine if there are many lines in your, let's say, your computer, so your board will be bigger and it takes more things to do. So that's the reason why in the past ang mga boards nila dagko jud. Okay? Dagko jud kay mga boards. Karon nagkagamay man no because you can get the same result with serial. Sure, in terms of speed, obviously parallel is faster. But right now, sir, paspas man si serial. Yeah, serial is faster because of the different technologies that is already been applied to those transmissions. Okay, but if we are talking just a plain transmission, obviously mas paspas si parallel. Okay, so those are some advantages and drawbacks of these things. Okay, what is parallel communication? So, parallel communication is a method of sending several data signals simultaneously over transmission link at one time. It comprises of several wired channels in parallel. So, in parallel mode of transfer, there is one-time transfer of data from source to destination. So, this is possible using multiple channel for data transfer between transmitter and receiver. So, again, there are channels that handles data transfers. Okay, so there are mediums in order for your data to be transferred and received properly. Okay, so like for example, the old computer printer. So right now we use USB, but in old times we use parallel ports. Okay, yan ang taas kayo. So DB25 man siguro ng klase ha. So we use parallel ports. But right now, you won't find anything in your PC like this, especially in your laptop. So mo na ang mga laptop nato karon nagkagamay. Until siguro ang ato ang mga USB port gamay na lang. Ang uban gali, di ba? Ang ubang mga laptop usa ka USB port na lang then type C. So because it could still function the same then nanay mga on OTG ng mga flash drives. So inga na, and then dili na kayo trend si flash drive, di ba? Cloud storage naman si trend karon. So most of our files are on the cloud. Okay. So like your Google Drive, your OneDrive, and other type of cloud storage. So mo na because there are things na dili na kayo inga na on demand. So ang mga materials sa ato ang computers nagkagamay siya. So nagkagamay siya, nagka nagkagamay pod ang space na gikinahanglan. So obviously nagka-compact ang ato ang mga devices na nato karon. So proceeding to the basic difference between a parallel and serial channel. So if you could see, so PCI we have this one. So mga ports SCSI, ISA, okay? Mga video card. So this one mga yeah, use video card also here. So Mamnisa, ISA, these are some examples of parallel communication. And even our board right now still have this one. Okay? Kana mga motherboard. But I think your laptop doesn't already apply this. But still there are some yapon. So manay na yung mga flex parallel magyapon na siya. But again, nagkanipis na siya. Nagkagamay, nagkanipis because it can be replaced with something else. Okay. So the difference between the two channels is its quantity of various of wires. As I've told you earlier, so one of the major differences is the number of wires in the physical form that is used for transmission of data between different devices. So in contrast to serial transmission, parallel data transfer use more than one wire. So, and that is excluding the ground and the positive. While for the what you call this USB or the serial channels, it just only use a wire for transmission and receiving. Which say ato ang USB we have four ano, ground and source and transmit and receive. Okay. So this mode of communication is expensive since it requires additional cables and hardware. That's what I told you earlier also that in the parallel it is more expensive since it has additional things to add. So nevertheless, it is considered to be a swift mode of transfer. For example, printer, RAMs, ISA, ATA, SCSI, PCI, yan ang mga pang slots ninyo sa inyong mga boards. So, mas faster gihapon jud, especially kanang mga high computing na mga devices na ginahanglan si parallel transfer. So, front device, bus, etc. use parallel data transmission. So, the decreasing cost of integrated circuit and the increasing consumer demand for more data exchange speed has made it suitable for suitable choice over serial link. Okay, so what is the evolution of the parallel communication? So obviously, there's a communication here. So it started with this and this and this, and yeah, it goes on and on. So it all started in the introduction of 8-bit parallel port, also known as standard parallel port by IBM in 1981. It was introduced as a fast interface replaced the dot matrix printer. So for the dot matrix printer kanang sabaan bitaw na tit 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 kanang mga gipino-pinong ano tapos mo porma. So I don't know if you see that one. Most of that you will be seen sa kanang mga I think naapagyapon na siya especially for payrolls, equip man kayo and gamit man gud ni siya especially mga payrolls or mga printing sa mga something receipt or mga vouchers or unsa. Kabantay ka nang may mga kilid nga na mga buho. So, gamit kayo mangguda siya. So, however, there was a major downside of this SPP or standard parallel port. So, the downside was that it was only providing one directional communication. So, one way lang siya. So, example, computer to printer, but there's no printer to computer. So the number of wires in the parallel port were left unused, which could have been utilized for indicating status of the printer. So on realization of various benefits of bidirectional communication, IBM made some upgrades or upgradation and brought a parallel port that supports both ways of data transfer. So that's the downside of the standard parallel port. Okay, that's the first that's the first history or the first example of the parallel communication. So on the realization, so the upgrade nila na siya. So in spite of the upgradation, parallel data communication was yet to make mark for suitable high-speed data port. So it had a various downside gihapon. So lack standardization of physical interface and limited distance, 6 feet supportability. Okay, the more uh, the more uh, magkataas ang wire, what happened man? So magkataas ang wire, what happened is that uh, there are more interferences that happen. So the more interferences that happen, the data will be distorted, meaning the data will not be as exact as what you intend to transmit. Okay. So that's the problem. So in this case, 6 feet ra ang iyang supportability. And again, as much as possible gali, kung mahimo na ara jud na siya sa mga 1 to 2 feet. Okay? Kay di yeah, na jud no, mga 3 feet siguro gamay na pud kay ng 1 to 2 feet, mga 3 o basta mga almost 1 meter nga na. Yeah, mga almost 1 meter. Ano advisable because the more than that interferences will be present. So karon, 'di ba? If we use mga USB, we have prolonged USB lines. But again, there is still interferences because of the resistance of the wire. So noises. So mo na yung mga mahitabo. So I don't know if you try sa when I was in college, our area wasn't good with with the signal. So hindi kaya siya. So I make my own disk. Okay. I put my broadband there. I plug it there. I put a USB. Okay, sa una wala may musod nga internet service provider. So we just buy kanang mga stick sa una, mga broadband stick. So I plug it in USB cable. So I take it as high as I can, and then so that I could find a certain tower na madawat na ako. But uh, as I've seen what happened, the more the wire I use, the signal is not accurate. So mag-fluctuate ang signal, meaning the signal could be fast, high, low, fast again, low. Then it will not be good experience for you, since it's not s- the flow of signal is not standard. Okay lang unta to if di siya nga nakapaspas pero continuous. So at least pwede ramang ka magpundo o signal. So from there, you need to cut those length. Kabantay mo sa ubang mga cables. Some of the cables have a tip na kanang murag lingin kaya kara ang mga chargers na ang tumoy sa charger is ang tumoy sa before isaksak nimo sa device kay na ay murag nimburot na murag that is to increase the current kay ning decrease na siya due to the resistance of the long wire. Okay. Mao na siya. Kamutan ng mga charger na mga karaan sa una, mga bugat pa kayo. So, mao na siya. So, kung wala na siya, mamandang uban na, ang uban na anadaan sa box nila. So, pasaka na nila. Okay. So, to overcome the downside of these two downsides, a standard IEEE 1284 was introduced for parallel communication. So, to solve that uh, drawbacks, 1284 IEEE standardized the physical interface to ensure a better interoperable conditions for parallel interface. So the introduction nullified the various drawbacks of initial parallel ports, such as ensuring the integrity and communication supportability up to 30 feet. So imagine, so napataas nila up to 30 feet. Sa una, it's just 6 feet. Now, na-improve nila into 30 feet. So the parallel port became more advanced with the introduction of enhanced parallel port or EPP. So from SPP, nahimo na siyang EPP. So enhanced. This use data cycles more effective and provide data transfer in real time. So maka real time transfer na siya. So also the enhanced parallel port increase the speed of parallel port from 100 kbps to 2 mbps. So in our time it's so fast, in your time it's so slow. Okay, I don't know. But it's basa ko. So next is evolution of parallel ports communication. These are the comparison between the standard parallel port and the enhanced parallel port in terms of this one strobe and the right. So it's used for computer to tell printer that it has a strobe. Okay, so to tell the computer that a complete character has been transmitted and is ready for printing. So while on the EPP, it indicates the write and read cycles in progress. So data transmission from computer to the certain then kini lang siya, one directional lang siya sa gihingon na from computer to printer. While on the enhanced EPP, so bidirectional siya, meaning from printer to device, then mo feedback siya sa status or anything na maka-baylo-baylo. So right now we are trying to sa ato ang case pod, what I need, what we will be doing in this as we progress is a bidirectional address and data lines. Okay, we will be applying that one. So yeah, we will go there as we go on. Okay, so especially in our laboratory. So for the here, the printer used by the printer total computer, it has received and printed the transmitted data and is ready for more. So interrupt request. So it used for by the enhanced parallel port peripheral to generate interrupt on the host of the computer. So interrupt request meaning so nag-request siya to interrupt some of the processes that is working. So in the na siya busy kini wait iya ha. So kawato niya. So kini nakalahi ani is nag-regulate siya pero ingon siya okay busy ko. So kini karyo sa so nakikitrabaho. It's like that basically. So these are the terms and comparison between the two parallel port. Okay. So how parallel communication works in a parallel communication, many bits, normally 8 bits of multiple of it, are transferred at the same time on various parallel parts or wire within the same cable in synchronization with a single clock. So the clock provides timing for transmission as a constant clocking signal through parallel paths. So as many bits are transferred over the various parallel paths at the same time. So the order of receive bits string may be different or out of sync, subject to various factors such as source, distance, location, and available bandwidth. An example of this is distortion or skipping in the internet call or the voice IP. So or and video streaming. So mga siya. So this is example of it. So from a transmitter, it receive at the same time. After that, it will be transmit at the same time. It will be received on the by the receiving end. So these are the characteristic of parallel communication. So number one, so before the development of high-speed serial communication technologies, the selection of parallel links against serial communication links was decided by the following characteristics. Number one is high-speed data transfer, limited cable length, and easy installation. So you need to address this one. You need to have a high-speed data transfer while having ma-solve nimo ang limited cable length pasabot mapataas pa nimo and dali ra dapat siya install. So the characteristic of parallel communication, so as we told, first is the high speed data transfer. The data exchange speed of the parallel communication data link is equivalent to the multiplication of the number of parallel paths and the number of bits at a unit of time. So meaning, oh, the the number of bits is transferred at the same time and you multiplied it with how many bits that one. So inga nakapaspasa siya. Therefore, the more is the parallel path, the higher is the achieved data transfer. So magkadagan ang wire na gamito nimo magka paspas siya kay naka intend naman siya intended na linya. So dili siya mag-ilog. Okay? So obviously, but it will go expensive. So limited cable length. As the length of cable increase, so does the amount of metal wires. This increase the chances of crosstalk manigingon ako. So kung makatikod mo bisan sa inyong UTP cable, okay? So mana siya unshielded twisted pair, yun ang cable ninyo. So magka-crosstalk na siya. There is the reason why kung makamatikod mo sa inyong cable, 'di ba, sa inyong mura sila gibawg-bawg, ana ng mga cable sa ato ang UTP. So at so to as lasanda crosstalk. Crosstalk means the interference between the cable wires and it leads to the unsuccessful exchange of readable data, which gives you a garbage value, as I've said earlier. So due to this effect, we cannot increase the length of cable beyond a certain safe limit. Owing to this factor, the cable length supported by a parallel link is quite shorter than serial link. So easy installation. So parallel data links are relatively easy to be installed as hardware, which in turns makes them a reasonable choice. So the configuration of parallel port in PC is quite easy as compared to its counterpart serial link. It is because almost all serial links require a conversion into parallel form using universal asynchronous receiver transmitter to enable its connectivity with a bus directly. So when to use parallel communication. When to use parallel communication. It should be used when there is a large data needs to be transferred, data to be sent in time sensitive, and data is required to be transferred quickly in real time. Okay? Those are the uses of parallel port. So difference between serial and parallel communication number one is no paths for data transfer. Serial link has only one path for data transfer while parallel has multiple paths. Distance coverage. Serial supports communication long distance while parallel has limited distance transmission. And crosstalk, chances of crosstalk is less in serial since mas gamay raman ang cable na gigamit. While parallel, one due to only one path available. So speed, serial link is slow compared to parallel one. Okay. Communication, serial transmission is full duplex as data can be sent or received at either end. Parallel is half duplex as data can be either send or receive. So cofactor, serial links are cheaper than parallel one uh, owing two more paths in the parallel mode. Complexity, serial links are simple and reliable while parallel links is obviously complex and unreliable. So these are some more differences. Okay, so I think mamaora man ni siya ani. So these are some more differences. So I think that's it for the parallel communications. But again, guys, we'll be applying this one as we go on, especially this 2 to 9. So we'll be trying to have a bidirectional address and data lines. Okay, so with your controllers. Okay, so